What's up guys, welcome back to another video here at Chief Academy, and today we'll be going through recurring decimals of fractions. Please like, subscribe if you haven't already, because I promise you, it is this easy. Our learn outcomes for today is to understand what recurring decimals are, how to convert them into fractions, and understand what the dot notation stands for. It's also to solve recurring decimals into fractions exam questions. So, what are recurring decimals? A recurring decimal exists when decimal numbers repeat forever. For example, 0.3 recurring means 0.33333 carrying on forever. The decimal never ends. However, these never-ending numbers can always be written as a fraction, such as a third in this case. In this lesson, we will focus on solving recurring decimals of fraction exam questions and understand the method we must use. As we stated before, a recurring decimal exists when decimal numbers repeat forever. The dot notation is used with recurring decimals. The dot above the number shows which number recurs. As we said before, the 0.3 recurring example, which can be put into a third as a fraction. The 0.3, the dot there means the 3 always recurs forever. But if I have 0.83 recurring, the dot is above the 3. So it'd be 0.8. Then 3 recurring that way. You can be asked to convert both ways, decimals of fractions or fractions to decimals. If you are going from fraction to decimals, simply use short division, and we'll do some questions on that in a sec. But if you're going from decimals of fraction, what you will get asked most of the time, definitely on the higher papers at the maybe midway to the end, you use the X method. So here I've used a 0.3 recurring example, and again, I put 0.3 recurring equals x, and then I've times it by 10 to get 3.3 recurring equals 10x. And as I have 0.3 recurring equals x, I do 10x minus x to get 9x, because then I've got rid of all my decimals, and I've just left with an integer. So I get 3 equals 9x, divide by 9 to get x on its own, so 3 over 9 equals x, and that can be simplified down to a third. You must put ellipsis, the 3 dots, or the dot notation when you're dealing with recurring decimals, as it states on the mark scheme to not award marks, and you'd be mathematically stating a different number, because 0.33 is not the same as a third, because 0.33 is 33 over 100, not 1 over 3. So you must always put the dot notation or the 3 dots, which is the ellipsis, when you're dealing with recurring decimals, or you will lose silly marks when you're doing it all right. Once again, it's that time to have a go at some Math Genie exam questions. Have a go, pause the video, and unpause when you've done. So, with our first question, we're asked to convert 2/9 to a decimal. And as I said before, if we're going from fraction to a decimal, we simply use short division. So, if we do 2 divided by 9 with our bus stop method of short division, we get 0.22222 carrying on forever, meaning our answer would be 0.2 recurring as a decimal. Now, in our second question, we're asked to convert 4/11 to a decimal. We do 4 divided by 11, and we get 0.3636 carrying on forever in that pattern. Here, we would put a recurring dot above the 3 and the 6. This would signify that it goes 36, 36, 36. If there was another number between 3 and 6, say 4, and that did not have a recurring dot, that would mean the pattern would go 346, 346, 346. Because, as we'll go with later questions later on, a dot and another dot signifies the start and the end of a pattern. Now, with our third question, we're asked to convert 5/6 to a decimal. We do our bus stop method, and we get 0.83333 recurring carrying on. Here, we put 0.8, then the 3, which is then recurring. Because the 8 is not recurring, as it only happens once, but then the 3 recurs after. So we put the recurring dot above the 3. With recurring decimal questions, you may see that you have more than one dot. As we stated before, the dot notation simply means that it goes on forever. This means that, as we saw before, 0.34, both with dots, would mean 0.34343434, carrying on forever. But 0.5 with a dot, 4 and 3 with a dot means 0.543543, carrying on. And if you're asked to divide or times with recurring decimals, put them both into the fraction form first, then divide or multiply. Because you may get asked to do, say, 0.34, which is both recurring, divided by 0.543, which is the recurring with 5 and the 3. Convert them into fractions first, then do the divide, like a fraction to a fraction, as it makes it easier to do. Here are some more exam questions for you to have a go at. Have a go, pause the video, and then pause when you've done. So, in our first question, we're asked to write 3.2, 5 recurring, 4 recurring as a fraction in its simplest form. See, if we put that to x on its own, we can times that by 1,000 to get 1,000x equals 3,254.54 recurring. And if we times x by 10, we can get 32.54 recurring equals 10x. The reason I've done this is our decimals will then cancel out with one another, which leaves an integer. So we get 3,222 equals 990x, meaning 3,222 divided by 990 equals x. And that, in its simplest form, is 179 over 55. Or if you've left it as a mixed number, it will be 3 and 14 over 55. Both answers are valid because one is an improper fraction and one is a mixed number, and it's both in its simplest form. Now, with our second question, we're asked to write 2.7, 4 recurring, 2 recurring as a fraction in its simplest form. We put that to x, and now we will times it by 1,000 again to get 2,742.42 recurring. Times it by 10, and we get 27.42 recurring. Now, we did what we did before, and we'll get 990x equals 2,715. And 2,715 divided by 990 will get us to x, giving us the answer of 181 over 66. And that, as a mixed number, would be 2 and 49 over 46. Now, with our third question, we're asked to write 3.5 recurring, 9, 4 recurring as a fraction in its simplest form. So we'll put that to x, but here we're going to times it by 1,000 again. We get 3,594.594. However, as our x and our 1,000x have the same decimals in the of 5, 9 and 4, we don't need to times x by anything else here. We can just use x on its own, because our decimals line up with one another. So here we have 3,591 equals 999x, meaning 3,591 divided by 999 will give it to x. So x will be 133 divided by 37, or as a mixed number, 3 and 22 over 37. Now it's time to have a go at some of the hardest exam questions you'll probably be asked on recurring decimals of fractions. Have a go, pause the video, and unpause when you've done. So, with our first question, we're asked to work out 0.3 recurring 9 recurring divided by 0.6 recurring 3 recurring. First, let's put 0.3 recurring 9 recurring into a fraction. So, 0.3 recurring 9 recurring equals x, and 100x is 39.39 recurring. As we have x and 100x with the same decimals, 3 and 9, we can simply do 100x minus x to get 99x equals 39. So 39 over 99 equals x, which can be simplified down to 13 divided by 33. Now let's work out 0.6 recurring 3 recurring. So here, 0.6 recurring 3 recurring equals y, meaning 100y equals 63.63 recurring. Like we did with our first one, we minus y, so 99y equals 63, meaning 63 divided by 99 equals y, which simplifies down to 7 over 11. As now we've got both our fractions, we would do 13 over 33 divided by 7 over 11. And as we divide by fractions, we keep change flip, meaning 13 times 11 and 33 times 7. However, as 33 and 11 have a common factor of 11, we can cross cancel. So this would cross cancel down to 3, and this would cross cancel down to 1. So we do 13 times 1 and 3 times 7. So our final answer would be 13 over 21. Now, with our second question, we're asked to work out 0.07 recurring divided by 0.1 recurring, 5 recurring. First, our 0.07 recurring equals x, meaning 100x equals 7.77 recurring. Now, we can't use x because we'll be left with 7.7, but we can use 10x, meaning we're left with 7 equals 90x, meaning 7 over 90 equals x. Now, for 0.1 recurring, 5 recurring, we put that to equal y, and we times it by 1,000 to get 185.185. We can just use y as it has the same decimals, meaning 999y equals 185, meaning y equals 185 over 999, or 5 over 27. So now we do 7 over 90 divided by 5 over 27. Keep change flip to get 7 over 90 times 27 over 5. But now, if we look at 90 and 27, we can see they have a common factor of 9. So we can cross cancel. So this would cross cancel to 3, and this would cross cancel to 10. Meaning we do 7 times 3 and 10 times 5, giving us our final answer to be 21 over 50. And that, ladies and gentlemen, is the end of today's lesson. I did say it was that easy. Thank you very much for watching. Please like, subscribe if you haven't already, and I'll see you in the next one. Goodbye.